We're going to talk about the curl in this video. Curl is sometimes called a rotation. We'll talk about why it's called a curl. Vectors are straight, they're not curvy, but vector fields can cause rotation, so that's where the name comes from. If you start with a vector field, mi plus nj plus ok, this curl is called del cross f. I'll make a note that's not a cross product. Again, this is bad physics nomenclature, but we'll go along with it because it's generally used. You can set up a quasi cross product, ijk, the partial operators, and then the scalar components of the vector field. And we'll move two columns over here just like we did when we calculated the cross product of two vectors and do the crisscross thing, except for instead of multiplying, for instance, we'll apply the y partial operator to O in times I. So there's a derivative and a multiplication going on here. And that gives us the curl. Now this takes a vector field and it produces a vector field. These I, j's, and k's show up in the answer, so we go from a vector to a vector. Take a simple example. Let's suppose f of x, y, z is yi minus xj plus 0k. That's not an O, that's a 0. We can set up our determinant, partial operators, y, negative x, 0. Now let's go ahead and calculate this. Now, at the very least, you should know how to calculate this. Partial with respect to x, partial with respect to y, y, negative x. Now, if you take this diagonal, take a y partial of 0, that gives you 0. I'll put all these terms in so you can account for them. And then we take a z partial of y, that's going to give us a 0. And finally, we take an x partial of negative x, we get minus 1k. Now we want to go the other way. And this one is minus by convention. Now we have a y partial of y, which is 1. And so we have a 1k with a minus, so it's minus 1k. And then we're going to do there, we have z partial of negative x, I, minus 0i. And then we have x partial of 0, which is 0, so we have minus 0j. And gather all this up, we only have two non-zero terms here, negative 2k. This is what's called a spin field. If you were to plot it, for instance, in the xy plane, for instance, it looks like this. You can plot the vectors out. Right here is 1, 0, 0. You end up getting a negative j. That's why it points on the negative y-axis. Likewise, if you go over here, it goes this way. You go over here. Okay, it's what's called a spin field. And you can take any, if you move up here to z equals 5, for instance, it's the same spin field. Z doesn't affect the vector field. You get the same effect. Now, we have negative 2k. You can take a point right here, plot the negative 2k vector. It turns out one geometric property of the curl is it's perpendicular to plane of maximum circulation. Here, of course, the circulation is in the xy plane, and the curl is perpendicular to it. You can use your right hand to go in the direction of circulation. Your thumb points in the direction of curls downward. If we were to make this negative, this positive, that would reverse the direction of circulation, and sure enough, the curl would be plus 2k. It would point upward. So that's a geometric property, and this comes into play when we talk about Green's theorem and Stokes' theorem. It's a very intuitive way of proving those basic theorems. So in terms of what the curl gives you, this gives you something called, which we will not define, it's something called circulation density, if that makes any sense. Probably doesn't, but that's okay. Okay, that's all for the curl for this brief lesson.